Hi, I'm Cheryl. In this problem, we're asked to approximate a double integral of x plus y dA over a region, where the region is a rectangle where x is going from 0 to 4 and y is going from 0 to 2. Once we use an approximation, we're then going to evaluate the double integral and see how close our answers come. All right, so to begin with, for this particular problem, we're going to have our double integral represented as an iterated integral 0 to 4, 0 to 2, x plus y, dy dx. So the first thing I'm going to do is, as the problem stated, I'm going to take my region, which is this rectangle from 0 to 4 and 0 to 2 on the y-axis, and I'm going to split it into 8 equal squares. So I'm going to bring this down and split it into 8 equal pieces. And then I'm going to find the center of each of these squares. So let's go ahead and find the center of each of those. All right, so what is the ordered pair for this point? Well, I'm going to be going 1/2 on the x-axis and across 1/2 on the y-axis, so that's going to be the point 1/2, 1/2. Moving to this point, this will be 3/2, 1/2. This point will be the point 5/2, 1/2. And that fourth point will be 7/2, 1/2. Now let's go ahead and find the centers on those 4 squares. So this time, along the x-axis, I've moved 1/2, but I've moved over 3/2. So that will be the point 1/2, 3/2. This next point, it'll be 3/2, 3/2. The next point will be 5/2, 3/2. And the last point, 7/2, 3/2. All right, so now to do the approximation, what I'll be doing is I'm going to be summing, and I should say approximately equal to, the sum from I equals 1 to 8, because I have 8 squares, f of x sub I, y sub I, times the change in A, which is going to be the area of each of those individual squares. Now, one thing that's important to notice here is that if you look at all the little squares that I've broken this down into, they're all going to have an area of 1 because they all have length 1 and width 1. Okay, so what is this f of x sub I, y sub I? Well, my function is x plus y, so I'll be adding the x coordinate and the y coordinate. So I really have the sum from I equal 1 to 8 of x sub I plus y sub I, and we said that was always going to be 1. Okay, so the first time through my summation, I is going to be 1. So I'll have x sub 1 plus y sub 1. So what I'm going to be doing is adding those two coordinates together. So that's going to be 1/2 plus 1/2, and again times 1. And I'll continue this process so that I have all of my squares taken care of. So I'll then have, let's move down. I'll have 3/2 plus 1/2 times 1 plus 5/2 plus 1/2 times 1, 7/2 plus 1/2 times 1, and that will give me all of my squares down the left side. Now I have to do the right side, so I'll be adding 1/2 plus 3/2 times 1, 3/2 plus 3/2 times 1, 5 halves plus 3 halves, times 1, and 7 halves plus 3 halves. Times 1. Now just to check, notice I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces, and I had 8 squares. All right, so let's go ahead and do some arithmetic here. I'm going to have 1 half plus 1 half times 1, that's just a 1. 3 halves plus 1 half, that's going to be 2 times 1. 5 halves and 2 halves, that's going to be 6 halves or 3. 7 halves and 1 half, that's 8 halves or 4. 1 half and 3 halves, that's 2. 3 halves and 3 halves, that's going to be 3. 5 halves plus 3 halves, that'll be 4. And 7 halves plus 3 halves, that's going to be 5. And if you add all of that together, you're going to get 24. So using this approximation technique, I'm guessing that double integral is going to be 24. Now, let's stop a minute and go ahead and actually evaluate that double integral using an iterated integral. So I'm going to go ahead and do the integral from 0 to 4, the integral from 0 to 2 of x plus y dy dx. Now remember, with an iterated integral, I'm going to start with the inside piece. My variable of integration is a y, so I'm going to treat all the x's as if they're constants. So the integral of x dy is just going to be xy. The integral of y dy will be y squared over 2. This will be evaluated from 0 to 2. So let's see, when I plug in my upper limit in for the y, I'm going to end up with a 2x, because I'm plugging the upper limit into y. So I'll have 2x and a 2 squared divided by 2, so that'll be 4 over 2, or 2. Then I need to subtract what happens when I plug in the lower limit. When I plug in the lower limit, notice the entire thing will be 0. So I'm just left with 2x plus 2 dx. Now I can integrate this with respect to x. So I end up with 2x squared over 2, so that's just going to be x squared, plus 2x. And I'll evaluate that from 0 to 4. Plugging in the upper limit, I get 16 plus 8. And when I subtract what happens when I plug in the lower limit, notice when I plug in the lower limit, again, I get 0. So I'm left with 16 plus 8, which is 24. Now, this doesn't always happen, but in this case, the approximation was exactly the same thing as my exact answer. I hope that was helpful. Thanks.